Welcome to the solution video for the change challenge. Let's start by going to File, New Project. We're going to select a console app, a .NET Framework console app. We'll call this Console UI, and this is the change challenge demo. Once we get this started, we'll do our console.readline at the end. And now we're really set up and ready to create our system. So let's talk through what we need to do. We first need to capture all the different denominations that we want to check for. All right. So I think what we would do for that is we're going to create a new class. Now I'm going to create it right here so we see it, and then I'll create a class file for it after we're done so we can have it in its own file where it should be. So this is kind of a handy shortcut. So public class, and let's call this denomination info. And then in here, we're going to need a couple of things. Let's go prop, and we have a decimal, and this is the amount of the denomination is. We could say denomination amount, or we could just say amount. I think just amount works fine. And then we should also have the name of it. So for example, so the amount might be 0.25, and the name would be quarter. Whereas, $1 might be a 1 for the amount, and $1 bill will be the name. Okay? So we need to create that list of items. So in fact, let's do that up here. So we're going to say list of denomination. Keep saying M instead of M. And let's just call it denominations equals new list. And now let's create a few of these. So let's say denominations.add new, like so. And then we'll start putting, let's say a name equals quarter, and the amount equals 0.25. Now for how much do they owe, and then how much do they pay. So let's do that right here. We're going to kind of shortcut this. This is one of those things where this is a practice app just to give us something to play around with. It's not a production app where we need to have all the stuff surrounding it. We're going to trust the user here. And that's one of my big tenets, never trust the user. But because the user is just us, it's just a test harness, essentially, to make sure that this works, then we'll be good to go. So console.write, please enter the amount owed. And this is where I would say we're going to trust the user. We're going to say decimal amount owed equals decimal.parse. We're not doing try parse here. We're doing a parse. So this will crash if you don't put a decimal amount in, or an amount that can be converted to a decimal. So just know that this is not something to give to users until you make it a try parse and then do some error checking to go back and say, nope, that's not a valid amount, and all the rest. Okay? All right, so there's our first one for amount owed. Let's just copy this and paste it again, and this one is the amount paid. So if they owe $9.85 and they paid $10, that's what we work with for getting our difference. Okay, so a difference is 15 cents, but there isn't a 15-cent coin, so what do we give them? We give them a dime and a nickel. Okay, so now what we're going to do is calculate our change. I think we're going to start with is actually the very the core of our calculation. So let's create a private static. I'm going to use a tuple here. So let me make sure first of all that my solution is set up for 4.7.2, which it is. You have to have, I believe, it's 4.6.2 or higher, I believe, will work for tuples. It may be 4.7 for actual tuples. If you have an older version, there is a NuGet package you can bring in for tuples that'll allow you to do that. So it's value tuple is the NuGet package. And if you don't know what tuples is, and I've said it like 5 times now, you're going to see in just a minute. So decimal, remainder, and int number of items. We're going to say calculate specific change, decimal amount, and decimal denomination. All right, so this right here is a tuple. Essentially, instead of returning one value, I'm returning 2 values. And the way that'll work is we'll actually have a variable that holds to what looks like properties, essentially. And the one will be remainder, the other will be number of items. In fact, the first thing I like to do is I like to declare it with a name and initial values. So I've said this is the type, which is the tuple. I give it a name, output, and then I declare the 2 values. What this allows me to do then is it allows me to talk to or assign to one of the values independently of the other without having to create 2 new variables. So for example, I can say output, if I spell it right, output dot, notice number of items and remainder. Okay, so in this case, I want the number of items. So I calculate how many items, which an item is, let's say you're passing in quarters. We're saying, give me all of the quarters. Well, then I'm going to pass back to you how many quarters fit into the amount. So you're passing in, let's say you're passing in 77 cents. And you're saying 0.25, which would be a quarter. So I'm going to do the division here and say, well, I can put 3 quarters into 77 cents without going over. That's 75 cents. So I'm going to return 3 for the number of items, number of this denomination, and I'm going to return 2 cents here for the remainder because that's what's left over after I put that many quarters or took that many quarters out of the amount. All right? So number of items equals math.floor. Now what math.floor does is it rounds down. always. Doesn't matter if you've got 0.99999. It's going to round it down. So math.floor for the amount divided by the denomination. So what does that do? And it's going to yell at me because it's returning a decimal. But that's okay because actually, if you read it, it says returns the largest integer less than or equal to the specified decimal number. So it actually returns an integer, but in a decimal format, which means that I can just do this. And that works, which is casting it to an int. So let's just talk through what math.floor does. In our example, we have 0.77 or 77 cents being passed in for the amount. And we're dividing it by 0.25 quarters, which gives us 3 I don't know, probably something like that. Maybe. I could probably do that math. It's a 2. Oh goodness, I think it's 8.1825, something like that. Anyways, that's what it's going to come back with. But math.floor says, I don't care what's after the decimal point. Just give me this value, which is 3. That would be the number of items, 3 quarters. Okay, so that goes in here. So now we know that there 3 quarters can fully go into 77 cents. Now what do we do? Well, we got to calculate the remainder. So output.remainder equals amount, that's the 77 cents, minus, let's put this in parens, output dot number of items times denomination. And you might be saying, well, why would you do that? Well, we've got to find out how much 3 quarters takes up. In this case, it takes up 75 cents. So 77 cents minus 75 cents equals 2 cents. That will go in the remainder. So now we can return output, which is a tuple that it's looking for. All right. So now we have both the number of items, 3, the remainder, 0.02 or 2 cents. So that's how we calculate one specific change amount. All right. So now what we need to do is we need to create a method that basically loops through all of these denominations and calculates a change for us. So private static list of string. Why list of string? Because I'm going to return back 1 or 3 quarters and then nothing for nickels or dimes, but then 2 pennies. So that way we know, okay, give them 3 quarters, give them 2 pennies, and you're good to go. So we're going to call this calculate change. You'll pass in the charge amount or the amount owed. Let's go amount owed. And then the amount paid. And then also a list of denomination info, which it will call denominations. Okay, so it's going to figure out, based upon the denominations you pass in, it's going to do the calculations for each of these. So let's start off by creating our output list. So output equals a list of string. So create that new list of string. And then we're also going to figure out how much change we need to give them. So the change is going to be the amount paid, not owed, paid, minus amount owed. So if you paid $20 and you owed $19.85, the difference is 15 cents. That's the change that you're owed. if change is less than 0, meaning if you owe negative $2, what does that really, or if you paid $20 and you owed $30, that would be negative 10, meaning you still owe $10. So output.add, you need to pay more. Now you could put in there, we could flip the sign and put that dollar amount in here. I'm not going to. You can do that if you want. You can do an else if and say change equals 0, meaning they paid exact change. So if they owed $20 and they paid $20, we don't do anything except output.add, no change required. All right. And finally, we're going to have an else. Now, what does else represent? Represents a number that's greater than 0. If we covered less than 0, we covered equal 0. So therefore, the else is anything that is greater than 0. And here, what we're going to do is our calculations. So let's start with getting an ordered list of our denominations. And the reason why is because what if and then penny. That way we get the biggest change possible first. So now we have this ordered list. Let's also set our variable called count. And this is going to be the variable that holds how many of an item came back. So we'll say for each, we'll say denomination in ordered denominations. And we're going to pass back change comma count equals calculate specific change, pass in our change and our denomination dot amount. All right, I'll explain this in just a minute. So actually I'll do it right now. So we need to pass in two values to our calculate specific change. First of all, the amount we have to work with. So how much money total? In that case, 77 cents, what our example was. And we have to pass in what the denomination is for the item we're dividing into it. And that's the amount, so 25 cents. So we're going to pass in a quarter. We're passing in 0.25. Well, we have this value called change, and that is the total amount we have yet to pay them. So we're going to pass that in, and we're going to pass in our denomination amount for the first one. It's going to be our highest amount, our quarter, and it's going to calculate the specific change. It's going to return how many of them, that's this count right here, and it's going to return how much is left after we do that. Notice it puts it right back into change. So it starts at 77 cents here. We pass that in and quarters. It says, okay, we're going to pay in 3 quarters, and what you have left to work with is 2 cents. What's going to happen then is the next time you go through the for each loop, it's going to pass in change, which is now 2 cents, and it's going to pass in dimes. It's going to return 0, and it still have 2 cents left. It's going to go through again with nickels and with 0, and then it's going to pennies. So we're going to say pass in 1 penny, pass in the change left is 2 cents. It's going to come back and say we have 2 pennies and we have $0.00 left. Okay, so that's how it's going to work. But once we get this change back, wow, there we go. My fingers weren't working. So once we get the change back, we're going to say if count is greater than 0, because this count right here could be 3 quarters, or it could be 2 dimes, or it could be 0 nickels. If it's greater than 0, then let's say output.add. We'll do our string interpolation. And we're going to say count. That's how many of them. And then denomination dot name. So 3 pennies, 2 dimes, something like that. Now, this name is singular right now. We put it in as quarter, dime, nickel, penny. So it's going to read a little weird. It's going to say 3 quarter or 5 penny or 4 penny actually, which isn't great. And what I'd probably do if I wanted to make this an actual application is I would have singular name and plural name. And then I'd come down here and say if the count equals 1, then use a singular name. And if the count is greater than 1, use the plural name. And then make it a little bit better. But for this, it's okay. We're just calculating the change. It isn't the worst thing in the world to have it be singular when it should be plural. Okay, so we're only going to add to the output if it's greater than 0. So we're not going to say 0 nickels. No one needs to care about things we're not giving them. We just need to care about the things we are giving them. And with that, it should be that we return output, and this method is done. So it's going to loop through each one, do a calculation. It's ordered it first to make sure that we go from highest to lowest. And in fact, let's just make sure that it's going to do that by messing up the order here. So now it's nickel first, and then quarter, dime, and then penny. And actually, let's put penny up one. There you go. So the order is definitely out of order. All right, so now that we could say result and results. Why don't you do that? Makes it a little cleaner. Console write line result. Just going to print out every result. Let's run this and see what happens. All right, so please enter the amount owed. Let's start off with, something simple. $4.26. The amount paid was $5, which means that, let's do this math kind of on our own, so we have it available to us to check. So that means that it's we're gonna owe back 74 cents, which is 2 quarters. That's 50 cents, which leaves us with 24 cents left. So that's 2 dimes. We have 4 cents left, which means 4 pennies. Okay, so we'll keep that in mind as to kind of our rough calculations. And let's kind of move these around so you can see both. And hit enter. 2 quarter, 2 dime, 4 penny. Exactly like we said here. Cool, huh? But what if you wanted to do more than that? What if you wanted to do, I don't know, dollars? Not a problem. Let's copy this and we'll paste it in. Let's go 1s, 5s, and 10s. $1 bill, $5 bill, and $10 bill, which this would be 10. This would be 5, and it's a U1. We hit start, we run this, and let's say we owe, $8.29, and we paid $25. I don't know why. One $10 bill, one $5 bill, one $1 bill, 2 quarters, 2 dimes, and a penny. Okay, that's it. So our calculator is complete. This one was not a lot of work really in some ways, but in other ways it had some tricky bits to it. So once this was figured out, then this was fairly easy to do, this calculate change. And this wasn't that hard either. But I tell you what, when I went through it, because I go through these first to kind of get a feel for what I'd like to do, I went through this, I think, 3 times before I was happy with my logic. Because what I do is I put down and I say, just get it to work. So I got it to work, and then I looked at it and went, yeah, that's not what I want. I want to kind of break out. For example, I was doing this manually. So for each line, I had an int quarter, and then I had a calculation. This was a calculation I did. And I have one for dime, one for nickel, one for penny, but that's all hard coded. And I'm like, well, what if I want to add dollar bills? Well, I got to add another 2 lines of code. And I said, well, that's kind of repeating itself. And so I created this right here. And then I said, well, if I've got this and I can do it for anything, then I can just create this little class down here and pass those in. And as long as I order it first, I'm good to go. And so I did that. And it took me a couple times to get it right, but this is what I ended up with for my calculator. Now we can throw anything you want at it in any order. So you wanted to add $20 bills and $50 bills? Sure, no problem. If you really want to, you can add a $2 bill. Yes, there is a $2 bill in the United States. It's just something we don't use very often. So we can add a whole bunch of different options here depending on whatever circumstance you want, and it will still calculate the change correctly. Okay? I hope you follow along. I hope you got it. Oh, one more thing before we're done. Let's not forget to do this. This class should not live here. But it was great while I was here because it allowed us to see it right away and see the properties. I can hit Control Dot and say move type to denominationinfo.cs. Click on that, it goes away. and it comes over here and creates its own little class that has it in it. So that's very nice. It's very helpful. And it's a nice addition to Visual Studio 2017 to be able to do that. So with that, we're done. I hope you follow along. I hope that you kind of track with me and maybe your solution is a little bit different, but hopefully you got to the same conclusion eventually. If not, try mine out, play around with it, try and build it yourself. If you haven't used tuples before, they're a fun one to play around with because it's nice to be able to return two things or more back, and you can actually name them like we did here, or you can just capture them as two different variables wrapped in parens if you want. Okay? Have a great day, and thanks for watching.